Okay. And then we're going to move this thing around a little bit, um, so that everybody can see exactly what we're talking about and doing. So just kind of background information. Region tools have been around since the 1950s, based in California. It was actually an offshoot of the aeronautical industry in that they made ground support equipment for Boeing and McDonnell Douglas to facilitate the building of the aircraft. So if you go to the airport and they're changing out the landing gear or a tire, you're going to see three big tripod jacks underneath the aircraft that lift up the entire aircraft to support it. And those tools, probably 75% of the US market is a Regent tool. So at that time, Regent also had the owner of Regent was at the country club with the president of Southern Cities Gas, which is SoCal, and he said, "Hey, how can we squeeze off our steel pipe?" And so part of that technology in the 1950s was, manufacturing a high pressure, high force, low pressure jack system to actively squeeze off pipe. The original documents on this required you to take a rosebud and heat up the pipe till it was cherry red, then put the squeeze tool on, squeeze it off, do your repair or your maintenance, then reheat the pipe and rotate the tool and install some rounding clamps um, to re-round the pipe to reinitiate your gas flow. We didn't appreciate that in today's safety environment and metallurgy environment, but this technology has been used since the 1950s all over the country and the world. Um, a lot of times we're using these for emergency situations. All hell's breaking loose, and you got to stop the flow of gas before you can put on your stopple equipment to actively stop off or valve off your flow. And that's the purpose of this type of tool. So the Mexico City earthquake, we got a call from Pemex that they had a 12-inch line that they couldn't shut down at all. And that afternoon, we actually air freighted a 12-inch tool to Mexico City so that they could stop the flow of their 12-inch line. So obviously, we don't like situations like that because it's somebody else's disasters tends to be our issue. That also happened, if you remember, in the 80s during the Atlanta Olympics. There was a gas line break on an 8-inch line that shut down the interstate for 6 hours during the Olympics. And so there and behold, a year later, here's a purchase order for a couple 8-inch tools for Atlanta Gas Light to have the proper tooling in case this emergency happens again. So that being said, you need the tool to work when you need it to work. Otherwise, for the most part, it sits in the corner and just stays there until something happens. Does anybody have any questions at this time? No, we're good. Okay, so this is the Regent 5045T. This tool is designed to squeeze off basically 3/4 inch through 2-inch pipe. Your maximum pressure that we like you to not exceed is 10,000 psi. It's a 38-ton force rated squeeze tool, and we have done some heavier wall schedule 120 pipe with this, although we don't recommend it. If you over squeeze or you over compress the pipe, you do run the risk of shearing the pipe. And so that needs to be kind of noted. The other thing that we want to watch and make sure is that if we're not dealing with an FBE coated pipe and we have some old coal tar epoxy pipe, that we skive off the coating so that we can see if we're dealing with an ERW or a seam weld. The seam weld, we'd like you to locate in the 12 and 6 position so that it's not at the 3 and 9 position in the jaw as you're starting to squeeze off that pipe, because it can overstress that weld and cause it to rip or tear. So care needs to be taken to know approximately where that seam weld is. So do you all, let's get a little background if you could for my knowledge. Do you all have pumps that look similar to the two pumps shown on the floor here? If somebody could answer that.
We have the hand pump on the left there at Clendenin. I think a couple other
Okay.
locations as well.
Yeah, so what you see is we have a manual hand pump. These are just basically Regent pumps that we get from XPX, a pump manufacturer. We modify them to have a gauge and a return that is correctly set up for our tool. Typically, it's just a simple hydraulic connection in it. We have a one-way feed on the hydraulics going down and a spring return on the tool coming up. So it's not we don't have a four-way valve on it where you're having to action to pump down and pump up. So the tool will operate with a variety of hydraulic pumps. So you have the manual hand pump. The manual hand pump has a dual stage piston in it that enables you to, once you cross over about 800 or 1,000 pounds of pressure, it goes to a smaller bearing assembly and piston plunger so that it's not difficult to pump up into the higher pressure. The pump on the right is a air over hydraulic pump, and that just simply is just an air over hydraulic pump, but they both operate the exact same. Care should be taken when you guys are looking at your pumps. You just want to make sure, obviously, you got fluid in the pump. I know that sounds kind of silly question to say, but that's true. We've had instances where the guy, has used the pump for other items and there's not enough hydraulic fluid in the pump. And also, what's important is that the pump is either level or pushing down towards the front. I'm going to ask Frank to kind of rotate the manual pump to the side 90 degrees so you can kind of see it in the camera a little bit better. And on this pump assembly, no, the other one, just 90. There you go. On this assembly, I know it doesn't sound like it's an issue that wouldn't come up, but we've had a situation where the pump had about 50%, 60% hydraulic fluid, although was being operated on the side of a ditch bank. So Frank, if you would rotate up from the connection vertical. So just lift it, yeah, like that. Well, that's kind of grossly exaggerated, but obviously the pickup head is in the front. So if you are on a ditch bank and you're having to operate it, please do it the reverse way so that we have fluid against the check valve for the pickup head. Otherwise, the pump's not going to operate correctly. I know that sounds silly, but we've had that happen. So the hydraulic quick disconnects are just simply a very simple Parker connection with a ball detent. You will have a little bit of oil that will seep out from time to time. That's not a big deal. We just use simply SAE 30 hydraulic fluid, nothing fancy. There's not any special fluid that you need to use with these. But what we want to do is take care to wipe the hydraulic connection before it's installed so that we don't have dirt or debris infiltrating into into the system. So Frank is just wiping the connections, and then he's going to reseat that in. All I did was there was pressure, so I released the pressure. And now we assembled this in. And then the same connection is on the tool. You want to go ahead and remove the connection from the tool, Frank? Then we'll go over kind of how the tool is designed and made. So as I said, we have just a very simple hydraulic connection on the tool. You can go ahead and leave that off for the time being. And if we could raise that up. All the way. Okay, so the Regent tool itself is set up. If you rotate that sideways, you can see the spring assembly. So the tool is designed so that we're pivoting and angling on two independent bars that enable us to kind of help find center. Kind of like polyethylene pipe. Not all steel pipe is perfectly wall thickness consistent all the way around the wall of the pipe, or the OD of the pipe, or the wall thickness of the pipe is what I'm trying to say. So we have this where it rotates and it's able to pivot to help find its own center. If you'd rotate it the other way, back to the front. So in essence, the Regent tools are designed on a hydraulic cylinder and a ram. The ram itself is what we thread. We have a lock collar that follows the ram down that completely locks out the hydraulics of the machine, so that even if you had a complete catastrophic hydraulic cylinder failure or ram failure, the tool will not release once it's locked down. That's a safety feature that we put in. So we don't use a ball valve or anything else to hydraulically lock the tool in place. And we'll show you that as it goes down. So the bottom jaw is has a pin assembly on it. So you'll simply release that bottom pin assembly. The bottom jaw will fall out of the way. It's pushed out of the way. You have it locked on that one collar there. And then the tool will, apparently we're having a technical difficulty with the tool. That bottom jaw will pivot completely out of the way. I get Ramon. Yeah, we've got a piece of debris in that on that top left. Anyway, so all good demos, you have a technical difficulty. Well, that's a technical difficulty. The bottom jaw should completely drop out of the way, and that's a hardened steel jaw set, and then you would install the pipe and then close the jaw and repin it. So let's go ahead and just close the jaw and repin it. We'll pretend that didn't happen during the demo. That can be a all that is, gentlemen, is there's ladies, there's the jaw set is on that bolt on the left side, point to the bottom bolt, and there's a hinge pin below it. And what's happening is that the hinge pin is not in the correct position. So we'll get that corrected, or it's got the sleeve on the is dropped down. That's probably what is done. So the other way that these jaw sets are set is the two top pins. Go ahead and point to the two top pins. And those two top pins are really what's holding everything in place. Those are case hardened steel pins. and designed for the stress of the tool. You can see how we have it strapped on the top jaw or the top handle. That is how we want to position it. Obviously, we don't want this to just be placed on. We do want to try to keep it in a vertical position as we're initiating the squeeze off, so that way it doesn't try to bend over one way or the other. So you do want to try to support this as you're squeezing off the pipe. Okay. So let's go ahead and we can just, let's hook up the hydraulic and we'll just do a dry run down a little bit so we can share the lock collar and how that's going to function. All right, so once that's assembled, you can go ahead and move the little cap away if you can, just slide that down. That's just a cap to dry that off or to keep the dirt and debris free. And at this point, I'm gonna make a little bit of noise. We're gonna go ahead and initiate a little bit of pressure with the pump. You want to concentrate on a tool if we can, get a close up of that as it's going down. So if you could center in on the camera for the threaded ram, that's what I'm trying to show. So this is the threaded ram assembly, and then this is the lock collar. So the lock collar is designed to go down, and what it does is it locks in place on the top of the cylinder. And therefore, if you had to go and do whatever you wanted to do, you can actually remove the hydraulics and block up the tool, and that is locked in place. Now, the issue is that once that's locked in place and the hydraulics are off, you're going to have to reinitiate pressure to push it down a little bit further to release the lock collar. So as you go down and it's locked in place and you do your work, or you have the situation corrected and now you're ready to release the tool, you're going to try to move that collar and it's not going to want to come up. So you're going to have to initiate just a little bit more pressure in order to re-energize the cylinder to relieve the stress of the lock collar. So that is a safety lockout device, and it follows the hydraulic ram going down. We have any questions thus far? Okay, so let's go through a demo on this. So when you're done, you can just spin that collar all the way up. Then I'm going to go ahead and release. And the tool, turn it to the side slightly. We have the spring return. Now, obviously, when you have pipe on there, the operator or whatever, you have the weight of the tool pushing down also, but the springs are what is retracting the cylinder along with the force of the weight of the tool on the top of the pipe. Okay. Go ahead, drop that down just a little bit. It'll make it a little bit easier to put in the 2-inch. That's fine. We can go ahead and put in a piece of 2-inch steel. So ideally, you would pick this up, drop the bottom pin, drop the tool over the steel pipe, retract the bottom jaw and repin it, making sure the pin's fully seated. We try to center this the best we can in that. And then we'll just, I'm gonna use the air over hydraulic pump. So I'm kind of old, and if I keep pumping on a hydraulic pump, I may have a heart attack. So I'm gonna do it the easy way. Just want to go down till it's centered in the in the tool, and trying to keep it, you know, centered throughout the tool. If it's not, you can release some of the pressure. So right now I have like just like 150 pounds of pressure on it, which means I'm in contact with that pipe. Is that better, Frank?
Yeah.
Okay. And I'm gonna just slowly go down. Can we get a picture of the gauge for me, please? So what you notice when we're squeezing off pipe, and I apologize for the camera and the glare, but basically the tool, as you initiate it, you're gonna see the gauge go from, let's say, 200 pounds to like 500 pounds or 800 pounds, and then it's gonna drop. And that initial drop is we're overcoming the hoop stress of the initial round part of the steel. Then it's gonna stay at the lower pressure for a period of time until we're almost metal to metal. As soon as we hit metal to metal, the pressure is gonna rise rapidly. And that's what we're gonna kind of show you. I'm gonna stop periodically to show you what that is happening. So we're just gonna. Stop here, show you where we're at on the tool, so you can see what the is happening to the steel pipe. Go lower with that. Pick up the tool just a little bit easier. Show me a picture of the gate again. So you can see that the pipe is starting to come down. You see the pressure is about 2,500, 3,000 pounds, but we're not down all. So I'm gonna stop here just for a second. As an operator, what we're doing is we're watching the gauge because we're not in the ditch. And I'm looking at that gauge. When I see that gauge start to rapidly shoot up, then I know that I am, you know, down metal to metal. At this point, as we're doing this, we also want to take the lock collar and go down with the lock collar. So right now I went from 3,000 pounds and now I'm already up to 4,500 pounds. That's telling me that I am basically almost metal to metal. So bear with us, we're getting things set up here. We get the camera in there. Yeah, just pick up the tool. Nope. Huh? Okay, so we're at like 4,200 pounds of pressure. Now at 5,000 pounds of pressure. So that gauge is rapidly shooting up, and that's how we know that we're down metal to metal and we're squeezed completely off. Oh, that's fine on the height. So at this point, we're gonna do the lock collar all the way down. And you show the lock collar all the way down, please. Okay, so the lock collar is all the way down. And if we release the pressure, which I'm going to do, so let me show you the pump. So I'm releasing the pressure. The tool is still locked in place. That's the purpose of the lock collar and the ram. So we go up to the threaded ram. So even if we have no pressure on this at all, yet we're completely locked in by the mechanical functionality of the lock collar. But now you can't release the lock collar because we have all the pressure pushing up. So in order to release the lock collar, you're going to have to go to the pump. To release the lock collar. And now the lock collar can come up.
You want to get the variety pack or just a regular ginger ale?
I'm sorry, sir. Can you say that one more time? That's right. So once that lock collar, go ahead and release the lock collar all the way up. So you would release the lock collar, and then at that point, I'm going to release the pressure on the tool after our work has been completed. And then the tool itself on the spring return is coming off of the bottom jaw and is retracting. Now you will get some bounce back on the steel pipe. Oops, don't fall down, Frank. You will get some bounce back on the steel pipe once it comes off of that, but we're going to go ahead and retract that and then remove that pipe. So the tool's just retracting back to its uppermost position. You can also, if the steel pipe is in the ground, you can lower the tool down to the top of the steel pipe. That'll help the spring return of the hydraulic fluid out of the cylinder back into the tool. And then let's go ahead and show the steel pipe itself. This is why we don't recommend trying to heat up or reround that pipe. Would clearly change the metallurgy in that pipe, but it definitely completely shuts down that heavier wall steel pipe.
And showing the external.
Yeah, you can show on the inside how it, it's still, it opens up after, it does have some elasticity to it that it's gonna bounce it back a little bit. So as far as maintenance and or just knowledge on the tool, I mean, obviously we'd like y'all to at least cycle these tools, once every 6 months. So that way, that it's operating properly and everything is functionality is correct. You will occasionally, if the tool's been sitting a while on the ram or on the hydraulic part of the cylinder, have a little bit of seepage of hydraulic fluid. That's not indication of a hydraulic seal failure. That's just you have a little bit of seepage and feel. The way these are designed and manufactured is there's a U cup ring and a O-ring inside the ram to the cylinder, and then that's got a threaded butt plate, not a butt plate, with end plate. Apologize. That compresses and locks that in. So sometimes if they've been sitting for a while and you have a little bit of seepage, that's not indicating that the tool is not going to function or work properly. And can also be repaired. But what we do want to check is that the pins are operating correctly, that there's not that the springs are going to return correctly. So just a simple quick down and retraction up will work fine. I recommend that, if you guys are going to use like a 1-inch or a 3/4 inch steel nipple to try to do this test, please take note that, some of the like 1x6s and 1x4 little steel nipples are not the best metallurgy. And if you go down and over compress it, you can shear that steel and shoot it across the room. So just please note that if you're going to test this, to make sure that, you have it either in a blocked box or an area where nobody's around for that steel nipple. Any questions? Pretty simple tool. When you need it to work, you need it to work. And that's why we try to keep it simple. We have one question.
He just raised his hand. So
Yeah.
if you raise your hand, please speak up and John will answer your question, or you can type it in the question and answer box.
Well, you probably have to turn on your speaker for that. Oh, you can hear it through this? Okay.
Brandon, do you have a question?
Well, this is Wayne. We're here with Brandon, but
We're still here. I'm just wondering if we do have I believe Brandon or somebody had a question. Brennan
And Patrick.
can you hear us?
or Patrick? Okay.
Feel free to speak up.
Can you hear us? Can you hear us?
Okay.
Oh, yeah, it's
I
hard
can
for
hear
me
you.
to hear. Bear
I
with
can
me
hear
one
you.
second.
You're wall to wall, Wayne.
Sorry about that. Try again.
We had the accidentally a technical difficulty with the volume. Okay, if you could repeat the question?
Can you hear us any better now?
Yes, absolutely. Thank you so much.
Well, this is Wayne. It's not Brandon. And
Yes,
I was wondering if the grade of pipe would have anything that would do anything, like if you use X42 or X65 or X70, if it would make any difference on squeezing it. Would that be
Well,
something that you should know about before you go into squeezing a piece of pipe for being, it could cause cracks or brittle?
yeah. I mean, if you could, yeah, absolutely. So this tool, the original design criteria for this tool was Schedule 40 and Schedule 80. That's what it was traditionally designed for. We had these things tested and certified up to 14,000 pounds of pressure. So that equated to the 38-ton nomenclature that we did for.
Well, that's the Schedule 40 or Schedule 80. You're talking about how thick the pipe is. That's not talking how hard the pipe is. Schedule 40, you could still have an X65 or an X70 or an X42 or 52 grade pipe and still be a
Correct.
Schedule 40 or a Schedule 80.
Correct.
You start getting in your harder grade pipes. I mean, you start squeezing it off. It will crack.
Okay. How would I can't answer that question. I can answer that question in the sense that I'm sorry. Yeah, I mean, we can, if you have some of that pipe, we could definitely do some test squeezes on it and see how that works. I mean, how would you handle that so when you're welding that pipe, do you have to put extra heat in that pipe in order to keep it from becoming brittle, or how do you?
Well, yeah, there's different criteria to different grades of pipe when you're welding it for sure about your post heat, preheat, and all that. But I know the harder the pipe, the higher chances of cracking if you're squeezing it. And I know a lot of these new prints and drawings and stuff that they put in, you can go in and check and see what the pipe probably is, what was installed. But I think that's something that ought to be included in this training, that, you probably ought to know what the material is before you're trying to squeeze it. And I mean, of course, it'll go with pressure it's on the pipe also.
Sure.
But it's different grade of pipe is going to squeeze a whole lot different than, higher grades is going to be, it'll be more brittle, if that makes any sense to you.
Yeah, no,
When it starts
absolutely.
squeezing.
Absolutely. So, I can't answer that. I mean, the only way I can tell you that we have squeezed for Southern Star on lines up in Missouri. Their pipe was like Schedule 120. And, they're using that for their farm taps coming off of their high pressure gas line. And these are the old farm taps, and they needed a way to basically, on a broken farm tap, go under it to squeeze it off so they could cut off and rethread on a new ball valve and then go and make a repair when they have a shutdown. But I mean, it never came up as far as, hey, is this X52 or X, 65 or anything. It was always related to us with regards to a wall thickness. And then that, of course, equated to, in order to shut that pipe off, we were upwards to like 75 to 8,000 pounds of pressure. I think we would just have to get some of that pipe and test it, or as part of y'all's service operation, to basically, hey, we have this pipe, we cut this out. Okay, this is in this section. Let's go ahead and do that as a test piece in the shop, so that you can understand, hey, when we're on this section of line, when we tested it in the shop, it took about 7,500 pounds of pressure to get it down, or did it split or try to embrittle the pipe? I don't want to come in and do a recommendation saying, take a rosebud and heat up the pipe to make it more malleable. That's just not something that we're comfortable in doing. And that's why we got away from that.
And Wayne, to be frank, we have not come across, or at least to the best of our knowledge, come across anyone who's squeezed that pipe with this tool. We're just not familiar with it. But like John said, we would definitely welcome an opportunity for y'all to send a sample and see what we do with it. And maybe it's,
Or send the tool, like. test it.
or send the tool, yeah, and you guys could test it, but, you know, another option would be possibly using the next size up tool, which has more pressure, which is our 5230, which is typically only more force. It's typically only recommended for 3 and 4 inch, but for that type of pipe and just a quick search of what it's metallurgy, its specs on Google, it seems like it's going to be a challenge with that 2 inch tool. That answer your question?
Yeah, I mean, I just feel that it's something that ought to be included when you ought to know the material you're working with before you start squeezing it. That's just, I mean, yeah, the thickness of the pipe, your schedule 40, 80, even 120 or whatever. A schedule 120 you wouldn't even have to push it as far because I mean you've got a lot of thickness in there. Your hole's already smaller, but that still doesn't tell
Yeah,
you
still
what
got
you're
a lot.
working with as far as grade of pipe.
Yeah, so.
Most
to
most
be-
your pipe's probably going to be an X42, X52 here. That's what they're using, but I mean you don't know that. You just don't know what you're working with.
Yeah, and that's some of our trepidation in dealing with this is, you know, the pipe is in the ground and it's been buried, and how long has it been there? What is it? You know, was this old thin wall war pipe? Was this super thick wall pipe? You know, what are you dealing with? Our typical, I mean, let's be, well, let me put this in my terms. So my terms are, if all hell's breaking loose, and this is one option to get you out of a situation, it's worth that option. So in other words, hey, let's do our best to get this thing down. If it's already blowing and you have a problem, even if you go down and that pipe starts to yield or split, at least your flow is going to be reduced. And that's,
Hey, and you may have mentioned it and I may have missed it, but what's the pressure recommendations on this thing? Like 300 pound,
75.
400
yeah,
as
as far
far as
internal pressure, we don't.
yeah, as far as like gas pressure inside, what's the recommendation for squeezing off? I mean, you don't want to squeezing off 800 pound, right?
Well, I mean, you could. I mean, you're overcoming I mean, 800 pounds of pressure, you're overcoming by the hydraulics of the machine. So, I mean, the
Yeah, but I'm
internal
not talking
pressure,
about. I'm sure the hydraulics will overcome it, but how about the stress on the side of the pipe with 800 pound inside of it? I mean, I know we can overcome it with the hydraulics, but I was just asking, does the tool have a recommendation on what the
no,
pressure could be?
no, we do not have a recommendation on what the pressure could be. It kind of goes back to, you know, we're not trying to reuse that pipe. So it's kind of like, remember on like polyethylene, if you block in a line with 2 squeeze tools, as you're decreasing that surface area, you're going to increase the internal pressure. We don't want to increase that over the MAOP rating of that pipe, right? But once again, on steel, you know, your smice should be set up that you're not going to get close to that. I mean, it's not like we're getting up to, now, yeah, if we got 3,000 pound line with 3,000 pounds of pressure in it, you know, now we got to overcome that 3,000 pounds with the pressure of the tool and the compression of the steel. That's not going to work. But 800 pounds, 500 pounds, we're not going to be too concerned with that. We'll be able to overcome that. I mean, once again, we're in what we would recommend the use of this tool for is for an emergency situation.
Patrick, do you want to ask your question?
Yeah, I know that we'll never be able to squeeze off a screw fitting because they're thick, but if you had a long radius weld-in fitting, have you ever squeezed in a fitting to shut it down if the situation wouldn't allow anything else?
Not to my knowledge. I mean, we have not tested it in under those types of circumstances. I mean, most of the ones that we have tested are like, little nipples or screw fittings or things like that. And or, cut pieces of steel pipe, and or pipe that customers have sent, for us to test it and see, how much pressure and what the qualification would be and everything else. But as far as a weld fitting, uh, no, we have not tested it under those circumstances. I mean, obviously, I think, yeah, go ahead.
Is there a recommendation how far you want to be from a girth weld, if possible?
Typically three pipe diameters is the recommendation that we've always had.
Are there any more questions?
Is there any reason why we couldn't use this turned in a horizontal position
No,
if the
not at
pipe's
all.
inverted?
Yeah, just as long as it's supported, so that's the way that Southern Star was using it on those flowing risers is, they would actually go in below and that's 800, 900 pounds of pressure that they were doing on that. They would go in below it in the horizontal position, and then they would start initiating the squeeze. And, yeah, you can do it in a horizontal position. It's just, obviously we got a little bit of weight hanging down, but, once it starts, it should hold it in that position without any problem. But yeah, you can do it in a horizontal, you can do it any way you need to get that tool on there. Any other questions? Yeah, I mean, the best way to do things is as you guys are coming across pieces of pipe within your system, if you have the opportunity to take out sections of that pipe, to use that as a test medium. So that way, hey, this was over on, this area, this was over on this area. And, you can see you just need a foot of pipe would be more than sufficient to initiate and see how that's reacting under the force of a squeeze. Um, then we can always do the calculation on the internal pressure and kind of see, all right, well, it's taken us about 6,500 pounds of pressure to get this completely shut off under this circumstance with this. And if we add 800 pounds of internal pressure, well, then we're adding that to it. So that would be the recommendation I would have to kind of get a benchmark to see how different pipe within your system is reacting under the squeeze. And as Evan said, if we need to go to, now our 4-inch tool will not do 3/4-inch pipe, but it will do, down to 2-inch pipe. So that tool, where this one has 38 tons of force, that tool is 75 tons of force. So it's quite, it's 265 pounds, quite a larger tool, but you can use that for, heavier applications. But that's still not going to help you if the metallurgy of the pipe is gonna become brittle and exhibit problems. So we're always around, and if you guys have a question or need a specific information or an answer, and we can be of assistance and do that, I'm sure that we can get you in touch with us at any point in time and be more than happy to address that. And as I said, if you have some pipe samples that you would like us to, hey, squeeze this off, see what happens to it, we'd be more than happy to do that.
Kendall, appreciate your time and exhibit today, if you will. We are gonna, in a few places, get our tool out and squeeze some 1 inch and 2 inch nipples or pipe. Just kind of comfortability, But any other questions, guys, around the company?
Just gotta thank Frank for his support today. He's done an exceptional job with that.
Way to go, Frank.
Yeah, thanks, Frank. Yeah.
But definitely appreciate the exhibit, and if we have any questions, we have your number. If nothing else, guys, we'll let you get back to work.
That sounds great, gentlemen. Thank you, and be safe out there. And if we can be of assistance, please give us a call, and be more than happy to help at any point in time.
And we do have a recording of this whole session today, guys, that we're gonna send out to you for reference. If you guys want to go back and look at something again, hear something again, we'll be sending that out shortly to you guys.
Thank you.
Much appreciated.
Yes, sir.
All right, thank you, gentlemen. Have a great afternoon.
Yeah, stay safe and happy holidays, guys.